Okay, got another equation written here, and this one you'll notice is a little bit different because it involves two trig functions. Generally speaking, if an equation involves two trig functions, I'm going to hope that somehow I can factor it so that I can have one trig function per factor and then set the factors equal to 0. And we'll be taking a look at that in the next video. Here, however, these aren't connected by multiplication. They're being subtracted. There's really no way that I can separate them, and this is a very special case. If I add the cosine x over to the other side, notice I get sine x is equal to cosine x. Now, if I had sine x equals cosine x plus a half, that's really hard to solve. But sine x equals cosine x, I can do. I just have to think a little bit carefully. So now, instead of looking for the quadrants where sine or cosine is just positive or just negative, I'm looking for where do they have the same sign. Okay. Now in quadrant 1, everything is positive. So sine x and cosine x will both be positive. They'll have the same sign. They could be equal to each other. In quadrant 2, sine is positive, but cosine is negative. There's no way I can have a solution in quadrant 2. In quadrant 3, sine and cosine are both negative. If they're both negative, they could be equal to each other. So I can expect to have a solution in quadrant 3, but I'm not going to have one in quadrant 4 because their cosine would be positive, but sine would be negative. And then I need to think about what's my reference angle. Now, because x here is an acute angle, this x, which is a solution, will be the reference angle alpha in this picture. It's going to be the acute angle that has the same sine and cosine. Well, I know what that is because that's going to be what shows up in my isosceles right triangle, because that way the opposite side and the adjacent side are the same. So that's 45 degrees or pi over 4. So here x would be pi over 4. Here alpha is pi over 4. So I would be getting x is pi plus pi over 4. That's 4 pi over 4 plus pi over 4, which is 5 pi over 4. So those are my two solutions between 0 and 2 pi. Now if I look for all solutions, I could take this plus 2 pi n, that plus 2 pi n, but I might notice that they're in diagonally opposite quadrants, and this is actually what I get if I add pi to that solution. So I can consolidate and say this is pi over 4 plus n times pi, where n is an integer. You'll remember we were able to consolidate our answers like that if we had tangent. I'm going to show you another way that we could solve this problem. I kind of like keeping it in terms of sines and cosines, but I could solve things in terms of tangents if I wanted to. Now, if I took this equation and I divided through by cosine of x, let's see what happens. That becomes tangent of x. This becomes 1. Now, caution. In general, you cannot divide by something that has variables in it, because in general, you don't know if that variable could be 0. And you're not allowed to divide by 0. So you've just done something wrong if cosine was 0. I can divide by cosine x here, because while I know that cosine of x is sometimes 0, I know that it's never 0 at the same time as when sine is. So if sine and cosine are equal to each other, neither one of them is 0. Now, if you're going to do that, I am going to be super picky. You got to justify it. If you're going to divide by a variable quantity, you have to tell me, and you have to be right, that you know that that variable quantity isn't 0. That's because it's going to be really tempting in some cases to try to divide by a variable quantity and then you lose solutions. We'll see that in the next video. Okay. So here it would be okay. So I would say tangent of x is equal to 1. And then I'm looking at what quadrants is tangent positive in. Well, 1 and 3. the acute angle whose tangent is 1 is pi over 4. That would be my reference angle here. I get exactly the same solutions. Okay. So just a slightly different way of thinking about it, but do be careful. If this is going to tempt you to start dividing by variable expressions, just keep it in terms of sine and cosine, because that works perfectly well.